Okay, let's take this particular function here. Then dy by dx at x is equal to 1 and y is equal to 1. So basically, we are going to find out dy by dx, which is, remember, also the slope of the tangent of this particular curve. Now again here, if you see, y has not been explicitly mentioned in terms of x. So x and y are all jumbled up together. So we call this as an implicit function. So we need to find dy by dx, which means you need to find dy by dx of both sides. So it's going to be dy by dx of x cube, which will be 3x raised to 3 minus 1, 2. Now here we are going to use what is called as a product rule. So we are going to find out x square into d by dx of y square. Minus 2 has been taken out. Then the other way around, y square into d by dx of x square. This is what we use over here. Then derivative of 5x, 5 into x raised to 1 minus 1, which is going to be 5. Derivative of y means d by dx of y, which is nothing but dy by dx. Derivative of 5 is 0. So let's see what all this we have. We have 3x square minus 2 into x square into d by dx of y square. Now first we use the same rule, that is for x. Y raised to 2, it means ny raised to n minus 1. So 2y raised to 1 into, again, since there is a function within this, we write it as dy by dx. So what are we doing? We first find the derivative of y square, then find the derivative of y, because it's a chain rule, so we use dy by dx. Then here you have y square into d by dx of x square is 2x plus 5 plus dy by dx is equal to 0. Now what we need to do in this case now is that it's going to be 3x square minus 2 into 2, 4x square y dy by dx. Let's collect this dy by dx together plus dy by dx. Okay, then minus 2 into 2x minus 4xy square plus 5 is 0. Now what we will do is we need to find out dy by dx. So we write dy by dx together and you get minus 4x squared y plus 1 is equal to, take all the other terms to the other side. So we have minus 3x squared plus 4xy squared minus 5. So dy by dx, either we take it down, let's do it that way, dy by dx is equal to minus 3x squared plus 4xy squared minus 5 upon 1 minus 4x squared y. Now at 1 comma 1, that's what they have said, is going to be minus 3 into 1 square plus 4 into 1 into 1 square minus 5 upon 1 minus 4 into 1 square into 1. This turns out to be minus 3 plus 4 minus 5 upon 1 minus 4. It turns out to be 4 upon 3. So ultimately you have found out dy by dx, and then so dy by dx in general is a slope of a tangent, but it's not valid unless and until you specify the point at which it is a slope. So here you specify the point whose coordinates are 1 comma 1. So for this curve, if you draw a tangent at this particular point, its slope is bound to be 4 by 3. So understand the implications of this. The same thing at another point, the slope of the tangent is going to be different, although the basic function is going to remain the same. So anyways, our guy is 4 comma 3. Let's check it. Yes, it is 4 by 3. The next problem goes somewhat like this. Okay, slope of the tangent at the point 2 comma minus 2 to the curve. So it's just similar to the same thing. So we find d by dx. So it's d by dx of x square, which is 2x. Then here you use the product rule, plus x into d by dx of y plus y into d by dx of x. So this is for this particular function. Plus y square, so it's going to be first ny raised to n minus 1, 2 minus 1. Then, since there is a function within a function, we do d by dx of y, that is dy by dx. Then minus 4, the slope is 0, 0, the slope is 0. So hence we get this. So we have 2x, we have plus x into dy by dx plus y into d by dx of x is 1 itself plus y itself plus 2y dy by dx. So we can substitute x as 2 and minus 2 over here itself, but let's do it the other way around, because often we are going to come across cases wherein you may have to find out dy by dx, and on the other side you have a minus of 2x plus y. So we have dy by dx as minus of 2x plus y upon x plus 2y. Hence we substitute the value. So minus of 2x, 2 into 2, 4 minus 2 upon x plus 2y, that is 2 plus 2 into minus 2, minus 4. So it's going to be minus 2 upon minus 2, minus 2 upon minus 2, which is 1. So slope of the tangent at the point 2 comma minus 2 to the curve is 1. Let's tally whether our answer is yes, we do have it as 1. Again, as we have here, the gradient of the curve 1 minus xy plus 2px plus 3qy is 0 at the point 3 comma 2 is minus 2 by 3, value of p and q. Now this is similar to the previous sums, but if you see in the previous one there was no variable. Here there are two variables p and q. So apparently we cannot solve this using just one equation. So we form an equation of the function itself. So we find what is the function, value of the function when x is 3 and 2 is nothing but 2 minus 3 into 2 plus 2p into 3 plus 3q into 2. Yes, the value of this function, and this is equal to 0. So that means this gives you 2 minus 6 plus 6p plus 6q is equal to 0. So we have 6p plus 6q is equal to 4. You can divide by 2. Divide by 2, you get 3p plus 3q is equal to 2. So we get one relationship between p and q. Now the other is we go the usual manner. We have to find out the derivative of this. So again, it is going to be d by dx of y, which is going to be dy by dx. Then here we use the quotient rule. Minus x into dy by dx minus y into d by dx of x. So we use this minus because minus is a common term. Plus 2p into d by dx of x, p is a constant, which is going to be 2p into 1 plus 3q into dy by dx is equal to 0. So eventually this is dy by dx minus dy by dx, and here you have minus x into dy by dx minus y into d by dx of x, which is 1, plus 2p plus 3q into dy by dx. Now we have to find out dy by dx and say that it is equal to, it's told that dy by dx is minus t by 3. So we take dy by dx common and you get 1 minus x plus 3q, this and this together, and you take the other things to this side, you get 2p minus y. So therefore dy by dx is 2p minus y upon 1 minus x plus 3q, and this has been given as minus 2 by 3. So it's told that the slope of the tangent, that is dy by dx, is minus 2 by 3 when the point is seen. So now we need to get the other equation. So it's going to be, this is minus 2 by 3 when y is so and so. So 2p when y is going to be 2 upon 1 minus x, that is 1 minus 3 plus 3q is equal to minus 2 by 3. So this turns out to be 6p minus 6 is equal to minus 2 into minus 2, 4 minus 6q. So you take it to the side, you get 6p minus 6q is equal to 10. In fact, you can take this as 1. So if you add these two, when you add these two, you get 12p is equal to, I'm having a mistake here, 3, 6p minus 6. Let's check this once more, dy by dx, okay, minus x into dy by dx minus y into dy by dx plus 2p plus 3q into dy by dx. So dy by dx, you have 1 minus x plus 3q, and oh yes, it has to be, when it goes to the other side, it's going to be minus 2p plus y. It's going to be minus 2p plus y plus 2. So it's going to be minus 6p plus 6. So it's going to be minus 6p plus 6q is equal to 4 minus 6 minus 2. So this you'll have to take it as 3. When you add the 2, you get 12q is 4 minus 2, that is 2. So q is 2 by 12, that is 1 by 6. So, and the other one, if you take substitute in any one of this, suppose you substitute in this q 1 by 6, so you get 3p plus 3 into 1 by 6 is equal to 2, and you'll end up getting p as 2 minus half. So there's no space over here, so 3p will turn out to be 2 minus half. So p will turn out to be 4 minus 1, 3 by 2 into 1 by 3, that is half. Hence you get p as half and q is 1 upon 6. So among these, it is half and 1 by 6. So basically, we are talking about a particular point. So using the coordinates of these 2 points, of this particular point, x and y coordinates, set up a relation between p and q because there are 2 unknowns. Then we do the usual thing, find the derivative and use this particular condition that the value of the derivative is minus 2 comma 3 when dy by dx has x as 3 and y as 2, which we did over here. And we get q as 1 by 6 and p as half. I'm sure this should be the answer. Yes, okay. Okay, then again x cube minus 2x square y plus 5x plus y minus 5 at dy by dx. We have done this already. We got the answer as 4 by 3. In one of the earlier sums, we have done the same thing, finding dy by dx and substituting x is 1, y is 1. We already come across the same example, and we got the slope as 4 by 3, right? Okay. The derivative of x square log x, again we're going to use product rule, so it's going to be x square log x. So it's going to be x square dy by dx would be x square into d by dx of log x plus log x into d by dx of x square. So x square into d by dx of log x is 1 by x plus log x into d by dx of x square is 2x raised to 1. So ultimately you get x plus 2x log x, that is x into 1 plus 2 log x. I think we come across this too earlier. So it's x into 1 plus 2 log x, that is option number B. Yes, it is. Okay. The derivative of 3 minus 5x upon 3 plus 5x the whole square. It has to have the whole square. So it's going to be denominator the whole square. 3 plus 5x the whole square into the numerator will have the denominator into derivative of 3 minus x. D by dx of 3 is 0. D by dx of minus 5x is minus 5. Then minus the numerator, that is 3 minus 5x into d by dx of 3 plus 5x, which is going to be derivative of 3 is 0, derivative of 5x is 5. So this, if you open the bracket, will turn out to be minus 15 minus 25x minus 15 plus 25x upon 3 plus 5x the whole square. Obviously these two get cancelled and you're left with minus 30 upon 3 plus 5x the whole square. So apparently it's option number C, minus 30 upon 3 plus 5x the whole square, and yes, it is. Alright, so we go ahead with this. I hope by now you're thorough with the various formulae you're using, the initial formulae. Derivative of x raised to n, derivative of e raised to x, derivative of a raised to x, derivative of log x, derivative of log a raised to x. We have been applying again and again. By now you should be thorough with the formulae. As told earlier, you need to memorize these formulae so that you can save on time and the chances of making mistakes are practically nil. So again, we switch back to the quotient rule. We have f of x is this. So f dash 1. So we need to first find f dash x, which is going to be the denominator, the whole square, denominator into d by dx of x squared, which is 2x, minus the numerator into d by dx of e raised to x, that is e raised to x. We can take out e raised to x common and you get 2x minus x squared upon e raised to x into e raised to x. So this is f of f dash x. So f dash 1 would have 2 into 1 minus 1 square upon e raised to 1, which is 2 minus 1 upon e, which is 1 upon e. So the option is 1 upon e. So whenever f of x is x square upon e raised to x, f dash 1 is 1 upon e. Yes, we do have this 1 upon e. Further ahead, let's see what we have here. Okay. F of x is 4 minus 2x divided by 2 plus 3x plus 3x squared. Then the values of x for which f dash x is 0 is what? Oops. Now this seems to be a big thing, but if you see, we have f dash x is 0. But so let's see. So we have here f dash x is something which we need to find. It is denominator the whole square. Okay, then denominator into derivative of the numerator, which is d by dx of 4, 0 minus 2x is minus 2 minus numerator into d by dx of this, of the denominator. Denominator d by dx of 2 is 0, d by dx of 3x is 3, d by dx of 3x square is 6x. So this is what you get. But now this f dash x has been given to be 0. It has been given. You need to find out the value of x for which it is 0. Now when you cross multiply over here, you get 0 is equal to, you need to open this, minus 4 minus 3x minus 6x squared minus 4 into 3 minus 12 minus 4 into 6x minus 4 into 6x, that is minus 24x minus 2x minus, that is plus 6x, and this is going and also minus 2 into 3x, this is going to be minus 6x. And finally we have minus 2x into 6x minus 12x squared plus 12x squared and upon 1. And that means this becomes a quadratic equation. 12x squared minus 6x squared, 6x squared minus 24x, and you have minus 4 minus 12 minus 16 is 0. So divide by possibly 4, no, 2. So we get 3x squared minus 12x minus 8. So we need to solve this equation to find the value of x. So hence obviously x is going to minus b. Minus b is minus 12 plus or minus b squared, that is 144 minus 4 into 3 12 into minus 8 plus 96 upon 2a, that is 2 into 3. So now what do we have here? So that gives you 12 plus or minus 240 upon 6. Okay, so this gives you 12 plus or minus 240 can be written as 16 into 15. 60. Yes, that's good. So this will give you 4 root 15 upon 6. We can take out 2 common or maybe 4 common, and you get 3 plus or minus root 15 upon 6. So this gives you 2, this gives you 3. Let's simplify this. So x turns out to be 2 into 3 by 3 plus root 15 upon 3 plus or minus 2 plus or minus, of course 2 plus or minus. So that gives you 2. Maybe you've taken a 2 common, so this will be plus or minus. So x is equal to 2 into 1 plus or minus. Since they are written in terms of root 15, this can be written as root 5 into root 3. This can be written as 3. This will go root 3 times. So eventually this x is equal to 2 bracket 1 plus or minus root 5 upon root 3, that is root 5 by 3. Now why do we do it this way? Because among the options possible, this seems to be closest. So x is equal to 2 into 1 plus or minus root 5 by 3. So basically you have done f dash x and switched over to a fundamentals of quadratic equations, that is using the quadratic formula. Hence the option here in this case is 2 bracket 1 plus or minus root 5 by 3. These are the two values of x. Alright, we do have it right. Okay. This is comparatively simple one. The derivative of x square minus 1 upon x is so and so. So derivative of course is dy by dx, or f dash x we can say, is denominator the whole square, denominator into d by dx of x square, that is 2x, minus numerator into d by dx of the denominator, which is in any case 1. So this gives you 2x square minus x square plus 1 upon x square, which is x square plus 1 upon x square, which eventually is 1 plus 1 upon x square. So f dash x is 1 plus 1 upon x square. Okay, so we have 1 plus 1 upon x square. Okay, differential coefficients of x square plus 1 upon x. When they say differential coefficient, they actually mean the differentiation of this gives what? In other words, what is the derivative of this? Quite similar, just like the previous one. Almost identical, only thing the previous one had plus, minus, here we have plus. Right? So, accordingly, you will end up, so x square plus 1 by x would be what? So, it is going to be the same kind of thing. Only thing is it's going to be minus 1 by x square. So the option is going to be B. It's going to be the same, minus 1 upon. There is another way of doing it, of course. is, I'll just explain it to you. You can even write this as x squared by x plus 1 upon x. So this gives you, that is, f of x will give you, f of x will turn out to be x plus 1 upon x. And then if you find the derivative, this will turn out to be 1. This is x raised to minus 1, so it's minus 1 upon x squared. We're using this, writing it as x plus x raised to minus 1. So using n x raised to n minus 1, you get this particular answer. Now if you find the derivative of this will be 1. This will be minus 1 x raised to minus 1 minus 1. That is minus 1 by x squared. The option is D. So you can do this using your quotient rule, or you could simplify and do it.